Okay, let's do 13 and 15. I think if you can do 13 and 15, you'll probably be able to do 14 and 16. So starting with 13, it's very similar to the ones that we've been working on in the last video. There's just one more step. Okay, so inverse operations, we are trying to isolate this 8p minus 6. So we got to get rid of that 4 and that minus 3. The first thing we're going to take care of is the subtraction, because we're doing inverse operations. We get 4 times 8 to the p minus 6 equals 90. Then we have to divide both sides by 4. We get 8 to the p minus 6. You're like, ooh, I don't have a calculator. Okay, how many times does 4 go into 9? Twice. With 1 left over. How many times does 4 go into 10? Twice. With 2 left over. How many times does 4 go into 20? 5 times. 22.5. And now we've gotten to the point where we've been before. So you could do, if I want to get rid of an 8 to some power, I want my base to be 8. Why? Because the log base 8 of 8, the log of any base, if the base and the argument match, is just 1. So if I want to get only a p minus 6 on the left, I need to do log base 8. Okay, so all this is going to go to 1, and I'll be left with p minus 6 equals, well, do on the one side what you do the other. I'm going to do log base 8 on the right as well. Then I'm going to add 6 to both sides. You don't add 6 to the 22.5. Okay? So p is equal to log base 8 of 22.5 plus 6. Okay? The only way the 22.5 and the 6 would be added together is if they had parentheses around both of those after the log. Okay? So in your calculator, it would look like this: log base 8, 22.5, close parentheses, and then add 6. So there's our solution for this one, for that one. And then number 15, we got a population. So again, we're looking now at a continuous, compounding continuously, and we know that because they're using p equals ae to the rt, or no, a equals pe to the rt. T is time in years. It's increasing at a rate of 22% each year. So they tell us the rate, they tell us the time. During what year? No, they don't tell us the time. They tell us the final. During what year? That's the question. Does the population of the city reach 50,000? So that is P of T or A. So let's look at, we've got 50,000 is equal to, what do we start with? Just 10,000. E to the 0.22 T. So how are we going to solve that? Just like we've been solving them, we're going to divide by 10,000. Okay, that 10,000 is just being multiplied by E. We don't need it to stay with that thing. It's much easier if we get rid of it. So 50,000 divided by 10,000 is just 5. And now we get something that looks a lot simpler. 5 equals E to the 0.22 T. And how do we get that out of the exponent? We use the natural log for this one, okay, because we need a base of E, and that's what a natural log does. So that means that 0.22t is going to come out of the exponent, and then we have times natural log of E, and the natural log of E is just 1. Okay, any log, same base, same argument, equals 1. And then we have the natural log of 5 over here. I'm going to leave the E off because we don't need it there. Alright. Divide by the 0.22, and you get that T is just equal to the natural log of 5 divided by that rate, 0.22. Alright, so that's the Intro to Logs assignment. If you have any other questions, hit us up in a comment, and we'll get back to you on it.